Hello, good afternoon, everyone. Yes, Shubham, do you have any doubt?
Hello. Yes, ma'am. Good afternoon, ma'am. Actually, my doubt is I haven't been enrolled in this course, but I am accessing this course through one neuron.
Yeah.
So will I be getting all the things but I'm not getting any like the pre-recorded videos and all those things. Like this dashboard, I can only see the live link. That's the thing. So
Um, I think I'm not sure that I think all the tech neuron people who have the access, they are also able to access the course
yeah,
which
I
is
can.
going on.
Yeah, definitely. I can access the
And
live classes here.
live classes plus on the portal you can't see the recorded videos of yesterday and the last week.
Yes, ma'am.
You can see.
Yeah, I can see the recorded videos, but the pre-recorded videos are not there. Plus, I cannot see the LCO. I mean, I don't know about what LCO and all those things, but will I be getting the like practice questions and all those things? Like, that's my question.
Yes, definitely you will get
Okay,
on the
okay,
portal.
okay,
Yeah.
ma'am. Ma'am, my second question is, I have been enrolled into this FSDS full stack data science course in iNeuron
Uh-huh.
only, and
Uh-huh.
currently I'm doing my internship. Like I'm doing some projects and all.
Mm-hmm.
So can you just tell me for clearing a data science interview or machine learning interview, uh, like uh, can you just tell me for cracking these kinds of role, how much DSA is needed? I mean, there's a lot of confusion going on. You should not know like very complex theory and all those things. So can you just tell me that?
So I can say that whatever content we are covering up in our batch, that much is preliminary or that much is required. So by saying that, you should know the basic understanding of whatsoever algorithms and data structures we do have. For example, array, linked list, trees, for example, graphs, divide and conquer module, greedy algorithms. So by saying that you should know the beginner and the intermediate level, but when we are talking about data science domain, hard level problems are not required. For example, in lead code, you will see three kinds of categories, right? Easy, medium, and hard. So if you are not into software engineering domain or software developer side, and if you want to pursue as a data scientist position, so you can skip that hard level portion of the questions. But by saying that, in order to solve easy and medium level, that also require the knowledge. Your fundamentals should be clear. So
Okay,
this
ma'am.
batch will give you the insight of all the fundamentals. After
Yes, ma'am.
that, this batch will provide you the easy and medium level problems only. For advanced level problems, very few we will cover up if time permits, not that much. And I think in order to crack any of the interview, whether you are a back-end developer, front-end developer, or data scientist, or data engineer, or data analyst, this much requirement is mandatory, at least in India, right? The very first round is always of a DSA round. If you can't crack that, no one will ask you to share your knowledge of data science. So that's the issue. Getting my point?
Yes, ma'am. Totally getting your point, and thank you so much for guiding. And one technical question was that whenever we talk about the trade-off between the space complexity and the time complexity,
Mm-hmm.
so can you just so is it okay to say that whenever we try to manage the space, like the time consumption will be more, or whenever we want to optimize the time, then in that case we have to deal with the more space or something like that.
Yes, it
So in
usually
ML,
happen practical real life scenarios, and even later on when we continue our discussions regarding the sorting algorithms, there I will show you practically as well that this thing is happening. That when we are trying to optimize the time, somehow we are making use of a space, and
okay,
there it is called as a trade-off between time and space. And at that point of time, we usually prefer time more over the space. So there is a very good example of merge sort that we will discuss in our classes, in the upcoming classes. Maybe I think after 5 or 6 sessions of analysis, when we will discuss that class, I will show you that this merge sort is something which is used everywhere whenever you are calling by default in Python, also when you used to call that sort function directly, internally
Okay.
that sorting algorithm is working on. So that sorting algorithm uses extra space, but it is giving us a lesser time complexity as comparable to other algorithms. That's why people are using that. So there
Okay.
is a trade-off, but we are obviously preferring time over the space.
Okay. Okay, ma'am. Clear, ma'am.
Clear?
And yeah, ma'am. And how long this course will go? Like, what is the time span? Like, what is
It's
the
like
plan?
whatsoever syllabus we want to cover up, it should be covered up. Usually when I used to take the batches, it will be covered up within 3 to 4 months.
Okay.
But by saying that, I genuinely want every student doubt should be clear.
Yes, ma'am.
So it might happen that it can go for long. For example, I remember my first batch was of 160 hours of live sessions.
Yes,
Even
ma'am.
though the syllabus was, if you can see, it's already in a self-paced mode is given in the One Neuron portal.
Yeah,
So
yeah, yeah.
there you can see that why that batch will go for long. The syllabus wise, I have covered up that much only. Obviously,
Yes.
that is the only syllabus for every class. It's not like that the syllabus is continuing changing. Every pattern is same, classes are same. But sometimes in some batches, students are so curious and they want to ask so many doubts. So the extension automatically happens to 5 months or 6 months as well. But that was the only batch which I remember. Their students asked a lot of queries and we did a lot of great discussions. If you will see the live batches of that, there are so many discussions going on, and
Yes,
that's
ma'am.
why that batch extended too long. I think 6 months that went.
Yeah, yeah, ma'am. That's
Otherwise,
that.
other batches will be of only 1 month or 2 or 3 months like that.
Even I saw I mean, I have purchased this one year on like long back, like 5 months ago, and I saw that courses and all those things. So it looks a little bit scary. Like I also thought that okay, fine, it's better to join live and then attend the classes because 160 hours of this marathon, like it look very
Yeah, so
scary. That's the thing.
the actual content is only of 50-60 hours, but
Yeah, yeah.
remaining just like you, people used to discuss, and then that also is going on in the recording. So
Huh.
that's why it seems too long.
Yeah, yeah. And joining the live classes, like it maintains the
Yeah,
pace
it
and it's
it
comfortable.
always it's always good to be in a live session other than, if you will ask from me what will you prefer, if suppose I want to learn from someone, so I will always prefer, even after paying some cost, I will always go for live classes because
Yes,
there is an
ma'am.
interaction between the two people, right?
Yes, ma'am.
So
And
yeah.
a short of like difficulties also I mean, we people are facing like the people who are there in the FSDS, like full stack data science course, they are having this class between from 3 to 8, and this course also starts from 3 to like that. So we have
Okay.
like a bit of time conflict and all those things. So I think I just thought of dropping a mail to INEED on that. Can you please just adjust some of the timing, like at least from 10 to 12 or like that, or 12 to 2, so that we can join both the classes in the single day and we cannot disturb our much of the time. So that's the thing.
I don't think that now they can change because
Yeah.
everything is already done.
Yeah,
And all,
yeah, man.
and there are so many students who did their changes on the schedule side.
Yeah.
But yeah, you can mail to them, and if they will find something, they will do for sure.
Yeah, because I'm attending this class and I'm missing that 3 to
I got your point.
yeah,
Yeah,
Sudhanshu
yeah,
sir class. Yeah, that's the
yeah,
thing.
yeah.
Yeah, thank you,
Okay.
ma'am.
Yeah,
Thank you,
okay.
ma'am, for motivating. Yeah, thanks.
Yeah.
Thank you so much.
Um, Abhimanyu?
Am I audible?
Yes, yes, please say.
Good afternoon, ma'am. Actually, I
Good
have a
afternoon.
doubt on yesterday's session. Could you please
Mm-hmm.
explain that example number 6 using the steps that you used on example number 7
Okay.
so that it will be more clear?
Okay. So have you guys tried these 3 problems which I given to you? Everyone? Yes. Okay. So yes, Abhimanyu, we are going to that point. Okay. Let me talk about these 2 questions because I have people ask these 2 questions, 6 and 7. Again, I will talk about that. Okay. So I think if we will discuss these three questions, then automatically the above two questions will be again clear to you all. So what I can do is that I can start with this questions discussion, and we will try to do these questions with the help of the same approach that I have applied in question number 6 and question number 7. Okay. So in that sense, our things will not be continue, and we will be able to understand other problems as well. So let's talk about problem number 1. So who will tell me the approach? Whosoever solved. Firstly, I'll ask from you and then we will solve. So first question says, what was the first question? I is equals to n. So let me write it first. So here, I am having the values which is equals to I equals to n. And here I am having while the value of I greater than 2, what we are saying is that I is equals to I to the power 1 by 25. And here I can print the value of I. Right? So this is the a priori analysis from where we left our yesterday's class. Who will tell me the approach? Who will tell me the approach? Okay, 5 people raised the hand. Tanveer, can you tell the approach? Tanveer, not speaking. Rintu?
Hello. Yes, ma'am.
Yes. How can we solve this question? Have
Yes,
you tried?
ma'am. Yes, ma'am. I tried. First, we'll take the I is equal to I 1 by 5 power 2k. Then we can add log to the both sides. Log n.
Can you repeat yourself what you are saying?
Yeah, ma'am. First, we take I is equal to 1 by 5 to the power 2k.
Okay. Okay. So you just break down that.
Yes.
Okay. So that
Then
is
we
fine. Yeah.
apply
Got it.
log both sides.
So
Then
basically, if I will talk about the way I used to do in the yesterday's class, because many of you all have a doubt on that. So talking about the similar kind of approach, maybe you can mute yourself. So here, what we can do is that I will try to apply the same approach here. What will happen? Try to understand those who didn't get the point yesterday. Same type of question. So here, if you will see, we are starting with the value of I is equals to n, right? So initially, the value of I is equal to n. So at every point of time, what we are doing is that we are making n to the power 1 by 25. In the next step, what I will do is that if it is greater than 2, I am doing 1 by 25 to the power 2. In the next step, I am doing 1 by 25 to the power 3. And so on. Can I do like this? Can I say? At every time, until or unless this condition will be true, I will repeat the same steps again and again by saying, doing the power of 1 by 25, 1 by 25, 1 by 25, until what point of time I should do that. Suppose I am doing this until 1 by 25 to the power k. So I am saying that until k times, I will repeat the same step. What is this k value? When I am stopping, what is the stopping criteria here? I will stop when this value will be equal to 2. Can I say? Because here I am saying I greater than 2. Can I say this? So here now, what you need to do is that you need to solve this equation, which is 1 by 25 to the power k, which is equals to 2. How you can solve that? Now here, if you will observe, I can take log base 2 on both sides. Why log base 2? Because on the right hand side, the term is 2. So I can easily able to get rid of this term 2 by taking log base 2, because I know that log 2 base 2 is equal to 1. Correct, everyone? So what I can do is that I can take log base 2 on both sides. So what I will do is that I will say log base 2 n to the power 1 by 25 to the power k, which is equals to log base 2. Now I know this value will be equal to 1, right? Now what I can do is that in logarithmic power, we can take the power term ahead. So it will be equals to 1 by 25 to the power k log of n base 2, which is equals to 1. Now what I can do is that I can take this term to the right side. So it will be equals to log of n base 2, which is equals to 25 to the power k. Now, can anyone tell me what log should I take to get the value of k? I am looking into the chart window. Very good. Log 25. Why? Because I know that when I will do log 25 and base is also 25, value will be equals to 1. I know this fact pretty well. So what I can do is that I will take log base 25, and inside that I already have log of n base 2. So here also what I can do is that this k value will come up front, log of base 25 and 25. This value will become 1. So now I will be able to get the value, which is the value of k, which is equals to log 25 log of n base 2. This is the value of k that we are getting here. So I can say that the time complexity will be equals to big O of log of n. Big O of log of n. That is the time complexity here. Any doubt? Ask. Yes, Bhargava.
Ma'am, through the rules of logarithms, taking log to the base 25 on the both sides, is it like mathematically valid? So I've seen taking log to the base n is possible. To the base 25.
Yes. You are taking same on the left and right. So is that impact the values?
No, it doesn't.
So that's fine. Right?
Yes, ma'am. In the second and third question, there also I was confused, like how to reduce the logarithms, because the two wouldn't come at the base there, and yeah, in similar way, I have to take the log to that particular respective base.
Exactly. Anyhow, we will discuss second and third, then also you will get better clarity. This is fine?
It's fine, ma'am. Thank you.
Okay. Yes, Abhimanyu, I think you asked the question. Still doubtful?
No, it is clear now. Thank you. Thank you.
Fine. You can, those who don't have any doubt, please unraise your hand. Rahul? Akshay? Yeah, Akshay, please ask.
Yeah, ma'am. Hello, ma'am. Good
Hello.
afternoon. I have completely understood this example. Just I have one doubt. Just take this slide up, ma'am. Below that I is equal to n, ma'am. N raised to 1 upon 25. I mean, it should, the power should be, means we are assuming that the power will be 1, 2, 3 up to the k. Means it is our assumption.
No, it is not our assumption. See the code. Here, if you will see, I is equals to n from where we are starting. Now,
Yeah.
what this code is saying that whenever your value of n is greater than 2, go inside. Here, what
Yes.
we are doing, we are saying I is equals to I to the power 1 by 25 in the first iteration. So first
Okay.
time when it will go, for the first time, we are saying, so what the value of n will become? N to the power 1 by 25. Am I saying it correctly?
Yes, ma'am.
Now, if you will go ahead, if the condition is again true, means consider whatsoever be the value of n it is. If the condition is again true, it will go again inside that. Again, what will happen? You will be having 1 by 25 already. Now again,
Yes.
what you are doing? you are doing 1 by 25 again. Am I saying it correctly? This is what this code
Yeah.
is saying.
Yes, ma'am.
So can I write this statement like this?
Yes, ma'am. Yes, ma'am.
Similarly, 3, 4, until
Yes.
what point of time you do repeat this task? Until this condition will become false. When it will become
Yes, ma'am.
false, when this value of I will be equal to 2. Can I say?
Yes, ma'am.
So
Yes,
that
ma'am.
is what I'm writing here at the very last.
Yeah, ma'am. Completely understood, ma'am. Thanks, ma'am.
Great. You can unraise your hand. Yes, Narendra. Narendra, do you have doubt? Yogesh? Yes, Gajendra.
Hello.
Yes, please ask.
Hello.
Yes, please ask.
Good afternoon, ma'am.
Good afternoon.
Ma'am, my name is Gyanendra.
Yeah, please say Gyanendra.
Ma'am, would you please take the value of n here for the example?
So here, for example, you can take the value of n maybe 64. So what is happening here is that 64 is greater than 2. Now what
Yes.
will happen? Your value of I will become, what will be the value now? 64 to the power 1 by 25.
Yes.
Now this calculation itself is very difficult. So you need some calculator here. But suppose you are getting some value. I have the calculator. So if you will do this calculation, 64 to the power 1 divided by 25. So you are getting some term which is like 1.18 here. So it will not go inside this while loop, right?
Yes, ma'am.
Here itself it stopped. Let me take some bigger number, maybe some value which is very high. Suppose this is a kind of a number which I am taking 3355543332. Now what will happen is that this number is greater than 2. So it will go inside this 33554432 to the power 1 by 25.
Yes.
Now here, if you will see this number, when you will solve this, you are getting maybe some value. For example, you're getting 4. Again, it will go inside this. Again, what it will happen is that it will again do whatever be the value you have on whole of 1 by 25, because this number is greater than 2. Am I saying it correctly?
Yes, ma'am. Yes, ma'am.
So the same thing is happening here. And so what is happening? 1 by 25 to the power 2. Now, suppose after solving this equation, you're getting some value which is equal to 2. Now, this value is the stopping criteria. And that is what I have picked up is the stopping criteria.
Okay,
Now,
ma'am,
the question is that how many number of times do I repeat this task?
Yes.
At that point of time, you need to calculate this value of k.
Value of k. Okay. That
Right?
will tell that will tell us how many times this program will.
Yes, this statement will get executed.
Ma'am, would you please tell me if I consider I greater than 5, then that time n की power 1 by 25 k is equal to 5.
So when you are saying here instead of 2 it is 5, right? So
Yes.
here instead of in answer you are writing log of n base 2, you will get log of n base 5.
Okay, then I have to put here instead of 2 I have to put here 5.
Yes, because here you will be having 5. So what you will do, you will take log base 5 on both the sides. So you will get in a final answer log base 5.
Ma'am, what is mean of log at log of 5? Matlab means what is means of log of 5 means stopping condition is 5.
No. See here, this is the equation that you are getting, n 1 by 25 to the power k, which is equals to 5. It means that stopping condition is 5. Means if when your term is equals to 5, this term will be equal to 5. You will stop. Your code will not run further. And that is true. Now, this is a mathematical equation that you need to solve to get the value of k. How will you solve that? For that particular thing, what we are doing is that we are taking a log base 5 on both sides. Why log base 5?
For making one right
For
side.
making one right side. So what I will do is that I will take log base 5 on both the sides. Here it will become like this, and here it will become 1, because log 5 base 5 will be 1.
Ma'am,
Now,
there is,
yes.
ma'am,
Ask.
I understood completely. Ma'am, there is any another way to solve this
No,
without
I
logarithm?
I don't think.
Only this way.
Yes. How will you find out this value of k? Any other way, if anyone can think of? I don't think. So that is the thing that you need to understand. It's just a mathematical equation. How you will solve to get that value of k is what you need to take care of. Right? Okay, then I think it is fine.
Thank you, ma'am.
The next important question which I gave to everyone is, if you remember, I is equals to 29. While the value of I is less than n, what we are saying? I is equals to I to the power 23. What is the answer you guys are getting? So who will tell me the approach for this? Exact. You just need to understand the stopping criteria. Things are very simple for you then. Here, if you will see, what is happening is that at each and every time, so here the value of I is equal to 29. So what you are doing is that you are doing 29 to the power 23. In second case, what will you do? Anyone? In the second case, what will you do? So you can write in the chat window, because I can't allow everyone. Yes, it will be 29 to the power 23 to the power 2. Right? So it will be something like 29 to the power 23 to the power 2, power 1. Now again, you need to check that until how many number of times should I keep on moving? So here it will be equals to 29 to the power 23 to the power k. What is the stopping criteria? What is the stopping criteria here? Anyone? Equals to n. Equals to n. Because when this value of I will be equal to n, at that point of time, obviously n is not less than n. At that point of time, obviously this condition will become false. So that is a stopping criteria for me. Now the only thing that you need to do is that you need to solve this value of k to get the final value, to get the final time complexity part. What you can do here now? Anyone? Exactly. I already one student already mentioned. What we can do is that we can take log base n on both sides. So what will happen if we will take like this? Log base n, 29 to the power 23 to the power k, which is equals to log of n base n. This will be equals to 1. Can I say? Now, what will happen? This 23 to the power k, we can take. How will you solve this equation now? Log base n, 29 to the power 23 to the power k, which is equals to 1. Anyone? Exactly. I think I got the answer from many students. So what we can do, we can take this upfront. This will be log of n 29, which is equals to 1. Now, what we can do? You can take it to the right side. Can we say 1 by 23 to the power k? Can we do like this? Everyone. Now what we can do? What we can do now? Again, we can take a log on both sides, right? So if you will solve this equation by taking log on both sides, you will get log base 23 log of n base 29. Try to be good with the logarithmics. Otherwise, you might face some trouble to solve these kind of equations. Right? So here, if you will see, again, what is the important thing to note here is that the important thing to understand is this equation. This equation. This stopping criteria, where is that? So here is the stopping criteria, this equation. So if you are good with this particular thing, after that, it's very easy. It's very easy. Just directly, you have to just solve that mathematical equation to come to that outcome. What is the third question? I is equals to 1, while the value of I is less than n. Internally, what we are saying? I is equals to 2 into I is equals to 3 into I. Who will tell me the answer? Very good. So many students have got the answer, log of n base 6. Who will tell me the approach? Pranav, can you tell the approach?
Yes. Can you hear me?
Yes, please say.
So first thing we can do, we can normalize the equation by 6 into I equal to 6 into I.
Yes. So here, if you will see, as a cumulative, it is written as I is equals to 6 into I. Right?
And
Now,
so for each step, we are like increasing I by multiplying 6 to it.
Exactly.
So if we take the log base 6, we will get like the stopping criteria of n.
So what is the equation that you are getting? Anyone? What is the equation of that stopping criteria here? So at every time, what you are doing? You are multiplying with the number. For example, here, if you will see, if the value of n is suppose 40. So what you are trying to do here is that you are saying I is equals to 1, 1 is less than 40. You are saying I is equals to 6 into 1. Right? In the next iteration, it will be 6 less than 40. It will go again inside. And you are saying 6 into 6. At the next iteration, it will be 36, which is less than 40. So again, you will do 6 into 36. Am I saying it correctly? So at every time, what you are doing is that you will be multiplying the value with a 6. So it's like a same example, I think, that we have understood in our last class. So if I will go back to the live 1 notes, you remember this example? Where was that? Have we discussed something like 2 into I?
Example 5.
Example 5 is I minus 3. Yeah, example number 6. It is exactly the same as example number 6. So here, if you will see, whenever we keep on multiplying something, if you remember what I told you at that point of time, here you're multiplying by 2. So it will be log of n base 2. I told you while explaining this point that if it is 3, it will be log of n base 3. Similarly, here, what is that in our question? It was 6, right? It was 6 in a way. So your answer will be log of n base 6. If you will try to solve with the help of one example, you can do that. What is the stopping criteria? Here it will be, at what point of time should I keep on multiplying this value 6 so that it will be equals to n? Right? So with the help of that particular thing, which is 6 into k is equals to n, with the help of that also, you can simply solve the equation and you can find out the answer. So the simple point here to understand is that it doesn't matter that whether you are solving it with the help of any equation, or whether you are solving it with the help of taking some random number value of n and then solving it manually. The important point here to understand is that whether you will be able to recognize that whether your code is taking n time complexity, n square time complexity, log of n time complexity, log of n time complexity. That is the very crucial point that everyone needs to understand here. And I hope that with the help of all these examples that we have covered up so far, I am making all these points pretty much clear to everyone. Any doubt? Please write in the chat window if you have, because step by step for everyone, unmuting them and then asking him, it will take so much of time. No doubt? Okay then. So, okay, these examples we have covered up. Now, what's the next part? We know that how basically we will be able to get a time complexity given a set of a code. Now, in the yesterday's class, many students, or maybe in today's class also, many students will have the doubt that which particular complexity is the higher one and which particular complexity is the lower one. That is the major concern, right? Which is the higher time complexity and which one is the lower time complexity. Now, how will we able to get to know that which one is having a higher time complexity and which one is having a lower time complexity? So for that, you should be able to get an idea of complexity classes. Complexity classes. This is a very important class. Please try to understand the complexities pretty well. So there is a topic which I want to discuss now, named as, you can name it as complexity classes. The very first, the very basic complexity will be the one. Who will tell me the answer? You can write in the chat window. What is the lowest time complexity? Perfect. Many students already answered it. It's a constant time complexity. So the very first class inside the complexity classes will be the constant time complexity, which is nothing but is equals to big O of 1. We already have discussed that this is the way to represent a constant time complexity. Secondly, after that, what we have is the logarithmic time complexity. Here, if you will see, it will be represented by big O of log of n. We already have seen this kind of complexity as well. And as I'm moving from top to the bottom, always remember I'm talking about a increasing order time complexity. I'm talking about a increasing order time complexity. Fine. After that, what will be the next one? Now, firstly, we will be having a constant. Logarithmic is having a more time complexity as comparable to constant. Next class is the linear time complexity class, which will be represented by big O of n. Linear time complexity, right? After that, the next class is the quadratic time complexity, which will be represented by big O of n square. Quadratic, right? After that, we will be having a cubic time complexity, which is big O of n cube. Big O of n cube. So now, if suppose someone is asking to you that write a code to solve any specific task, let me go back to the previous example, which we have discussed in our first session, yesterday's session. And I will ask you the same question now that I talk about, that I will come back here. After some point of time in yesterday's session, I talked about that there is a student called Dharun, there is a student called Arvind. The question is same, that we need to add, or we need to do the sum of 10 natural numbers. One person or one student named Dharun did by applying one for loop. And another one just uses the formula of sum of n natural numbers and give me the summation. In both of the things, I'm getting the correct answer. Now, can you tell me which one is having a good approach? Arvind is better. Why? So can you tell me what is the time complexity requirement for the Arvind? Constant. Because we are not using any kind of a loop here, right? But for Dharun, what is the time complexity? Big O of n, right? So now see how easily you guys will be able to answer to me that same question. Why? Because we know that the constant time complexity is lower as comparable to the linear time complexity part. That's why given the code for Dharun and Arvind, even though they are giving me the correct answer, even though they both are giving me the answer as 55, I will go for the Arvind code. That's why analysis is important. To compare the solution of the same problem, having different solutions, which one is having a better approach. Now see, instantly you will be able to get an idea that this is the approach which is better as comparable to that one. But yesterday when I asked the question, maximum students are not able to answer that. Or even if they are able to answer that, they don't know the logical reason behind that. So that's the simple thing that you have to understand here. And that's why this complexity classes are very important. Similarly, suppose some problem is given to you. There is one student who is solving that problem in cubic time complexity. And there is another student who is solving the same problem in linear time complexity. Which one is better? Which one is better? Linear. So at that point of time, you will go for a linear based time complexity. Right? Okay, one student in the chat I have seen asked one question, that one other complexity class that we have studied while solving the priori analysis questions, which is log of n. What do you think? Where out of these categories, whatsoever I have mentioned here, this category will belong to? Between 1 and 2, between 2 and 3, between 3 and 4, between 4 and 5. Between 1 and 2, correct. Why? Because as I also talked about in yesterday's class also, that taking the logarithmic and after that taking log of that means you are converting a value which is more smaller than that. So here, and in this category, it will be belonging somewhere here. Big O of log n. Right? Okay. Moving ahead. There is a class called as polynomial time complexity. Now here, if you will see, big O of n to the power c. So here, if you will see, this constant c is very important to understand. If the value of c is 1, it's linear. If the value of c is 2, it's quadratic. If the value of c is 3, it's cubic. And if the value of c is more than 3, you can consider that as a class of polynomial time complexity. Right, everyone? Clear? Now, coming towards the next important class, which is the exponential time complexity. So in exponential time complexity, it will be like order of c to the power n. Try to see the difference between these two, polynomial and exponential. Here what I'm saying is that, for example, you will be having big O of 2 to the power n. So this is a kind of a time complexity which is higher as comparable to the polynomial time complexity. Making sense to everyone? After that, so here what I'm saying, n to the power c, c is constant, means I am saying that, for example, you are saying big O of order of n to the power 3. And in other sense, you will be having 3 to the power n. This is a class of a polynomial time complexity, specifically called as cubic complexity. This is a class of a exponential time complexity. If someone is asking to you which one is higher, so which one is higher? exponential. This one is higher, right? That is the thing that you have to understand here. Now I will talk about some relations, some correlations between the values that is very important. We have an example of this is an example of exponential only. Okay, in terms of solving that prior analysis, we will solve many examples. So here, if you will see, the next important relationship that you need to understand is the relationship between factorial and n to the power n. This is the kind of a complexity which is very high, very, very high. Then there comes something called as exponential and n to the power n. Here also, if you will see, the exponential time complexity is somewhere very high as comparable to this n to the power n. What I am saying is that, and this n factorial time complexity is greater than 2 to the power n. What I want to infer from these three equations? Simple thing which I want to make you understand is that this 2 to the power n is having a lesser time complexity as comparable to the factorial one, which is further less than the n to the power n. Very important thing, because these kind of complexities are sometimes it can be asked, and you should know that what is the relationship between the factorial, the exponential, and the n to the power n thing. Fine to everyone? Next important class that you need to understand is that what is the relationship between log of n and n. In 8th one, what I'm saying is that the highest time complexity is n to the power n. So far, we have seen that exponential is the highest one. But here, c is constant. But instead of c, if you will be having that n again, so here it will be n to the power n, which is very, very high as comparable to other time complexities. N to the power n means, for example, you are having the value of n as 16. You are having 16 numbers in your array, in your data. So your code is printing that print statement 16 to the power 16 times. These many times your code is repeating again and again. Right? And here, in a practical scenario, we are not dealing with very small numbers. We are dealing with very huge numbers. Everyone should be aware about that fact. So if suppose I am dealing with some numbers, maybe 1000 or 1 lakh numbers are there, at that point of time, you can imagine that how much high is this time complexity, n to the power n. That's why there is a relationship between these three specific terms. Factorial is coming in between. Highest one is n to the power n, and the lower one is exponential when I'm talking about the comparison between these three things. Another thing which I'm saying here is that suppose you are having a log of n and then you are having a n. Which one is having a higher time complexity? N, right? Can I say? If I will do the squaring of this, suppose, and still I'm writing here n, what do you think is having a higher time complexity? Still n? Great. If I will do the cubic of that, and on the right side I am having n, which one is having a higher time complexity? Still you guys are saying n? Perfectly fine. Now try to see one thing. If I will keep on making a power with some any arbitrary number, it's completely fine. Power of 3, power of 4, power of 5, power of 1000 also. If I will write here, it will make n as a bigger term only. But one thing now you need to understand. If I will make as log, I am mentioning in as a power of log of n, and here it is n. the relationship completely reverse. This is the important thing which I want to tell you here. Why? Can anyone give me the reason of that? Why do you think this particular thing will be holding true? First of all, do you think it is true? I can just prove you within 1 second of statement. If you can do little bit of maths, you will be able to see that this statement is true. How? Again, what I can do is that I will take log on both sides. I will take log on both sides. So when I will take log on both sides, this log of n will come up front. So can I write like this? Log of n, log of n. And this is also log of n. Base is n, I am taking, so base is n. Here if you will see, everything base is n, this will be cancelled out with each other. This will be equals to 1. Here if you will see, the right side is having some value, but left side is not having any value. Right? So here on the left side, if you will observe, you will be getting some data, but on the right side, there is nothing. So that's why if you will observe that this statement, whatever I am mentioning in the lower part by green marker, is true. So what I'm saying is that I am saying that when you are doing a power 2, power 3, power 4, power 5 until 1000, this is fine. This relationship will hold true. This, whatever you said, is correct. But in the power, when log term will come, relationship automatically gets changed. That you need to understand why. Another important fact. Suppose I am saying there is something called as 2 to the power n, exponential time complexity. There is something called as 3 to the power n. What do you think is the higher time complexity part? Three to the power n. Why? So you are saying this one is bigger. Why? See, 3 is greater than 2. Don't give me these reasons. We are a mathematics students. We should know how we can apply mathematics to prove this. Can I write this 2 to the power n? And here I can write 2 into 1.5 to the power n. Can I write like this? Here, if you will see, we can write it like 2 to the power n into 1.5. So basically, if you will see here, there is some number which is 1.5 to the power n, which will be added here as a multiple. That's why I can say that the statement is having a higher value. Tell me the answer. Can I say? Simple, right? So everything, whatsoever I am writing here, there is a proof of that. You just need to get the justification correct. Right? Okay. I think we are good to go. Now, one more important thing which I want to keep telling to many students, because many students don't know this property also. Whenever you are having a log of n, suppose there is a base 2 and here is a base 3. What do you think is the bigger one? So there is a confusion here. See? So always remember in logarithmic, lower the base, higher the value. So here 2 is having a lower base, means this is having a higher value. Lower the base, higher the value. Is that fine to everyone? Now, in complexity classes, so these are the majorly classes which I want to talk about. I am not going in much more depth, but yes, these are the ones which everyone should know. Basic, fundamental complexity classes. If you have any doubt in these classes, please ask. See, whenever you guys are in the live sessions, no, one simple humble request to everyone is that I'm seeing that, okay, maximum students might be having the focus in the class, but don't work for distracted things. What is distraction as of now? This WhatsApp link, which is zooming on in the chat window. So you can discuss all these things maybe after the session or maybe before the session when you are coming in the class. But when we are in the class, please focus on whatever I am explaining here. Don't distract yourself as well as you are distracting others also by sharing those links. And only those students will ask the question in the WhatsApp group who are not attentive in the class, in the live class. They don't know what's happening as of now because they are busy in sharing the links and adding in the groups. And after that, what discussion they will do? Because they're not listening here. Simple. Be attentive in the class so that you don't even need those groups. Now I think you can't chat with each other and you can only chat with me. I can only see the messages. There is no general solution of time complexity that will be applicable for all types of problems. You just need to understand here that what's the approach that we are using, and it simply depends and varies from one problem to another problem, that what kind of approach should I use to solve that. And at the very end, it's just the practice that you will do. And I'm pretty sure that the way we will, it's a very beginning classes. That's why maybe it's quite making you anxious. But when you will solve more problems, till now we didn't started the implementation, right? We are just focusing on our analysis part. Whatsoever things you will be able to grab in the sessions, grab it. It's good for you. Whatsoever you're not able to get it, it's completely fine. Why? Because in the complete course of these 3 months, 4 months, we are doing this only. We are doing the implementation. After that, we will again and again talk about these things. What is the time complexity? What is the space complexity? These things I will talk a lot. That's why I am starting from here. Okay. So whatever you're getting, it's good. Whatsoever you're not getting, no point of demotivation at that point of time. Just try to grab whatsoever you can grab from these sessions. And after that, once we will start the implementation side, everything will become easy for you. Because at least if you will be able to get the 50% of the session, whatsoever I'm explaining here, you will be able to correlate the things in the future part. Okay. Okay. 9th point is saying that when you are doing a power with any number, which is 2, 3, 4, 5, 7, at that point of time, the value of n will always be greater. But when you will do the power as a log of n, automatically relationship will get reversed. Means now this term, log of n to the power log of n, will be having a higher value as comparable to the value of n. Right? Chinmay, when we will move towards recursion, then you should ask this question that how we will calculate the complexity when we are dealing with recursion. Right? 11th point is simply speaking that when you are having a lower base, let me write it here as well. So when you are having a lower base, then you are having a higher complexity. in logarithmic. This is the property that everyone should know. That's why I have written here. Okay. So that is the important thing that you need to understand. Okay. Lower the base, higher the value. That's the important point. Fine. After going towards this complexity classes, here if you will see, we have seen that, okay, given a set of a code, how we can calculate that big O time complexity, or what is the order of the complexity classes that we have. But now one thing which I want to talk about, and which I have talked about in the yesterday's class, but not in that much depth, is about the asymptotic notations. Right? What does that meaning? The simple meaning is that what is the mathematical idea behind the notations that we know, which is big O, that we already have seen in terms of every calculation we are using big O only. And the reason I have already clarified that this is giving us the worst case scenario. This is giving us the worst case scenario. Then we are having a omega notation, which is giving us the best case scenario. And then we are having a theta notation, which is giving us the average case scenario. Today, we will try to see that mainly how basically we will be able to see as a mathematically intuition behind that. What is the meaning of big O mathematically? What is the meaning of omega? What is the meaning of theta? Right? Yes, big O doesn't play that big a role in big O time complexities. It's true. But sometimes, suppose when you are going for an interview, you are dealing with the MCQ based questions. 10 or 15 questions they usually ask as an MCQ, and after that they will go towards the coding round. In that, suppose they have written the base. They have written the base while talking about the time complexity. At that point of time, when I'm saying big O, you need to take the worst case scenario, which is having a lower base, because you know that particular time complexity is higher as comparable to this one. So at that point of time, you might need this particular knowledge. That's why I have written this. Otherwise, in maximum scenarios, yes, whenever we are talking about base, it doesn't matter whether it be 2 or 3, we simply write like this, big O of log of n. You are saying it correctly. Right? So shall we go towards the intuition behind these asymptotic notations? Everyone? Is everyone ready? Perfect. Let me drink some water and then we can start. Okay. So let's get started. So when we are saying big O, O is the symbol to represent. When we are saying omega, omega is like this symbol that you will see. When we are saying theta, this is the theta. Fine. This is the way to represent these notations. That's it. Now, I hope everyone remembers, in yesterday's class, I have given you the example also of a practical real life example. When suppose there is someone, you want to see the nature of your friend, then you will obviously go for the time when you are in your worst case scenario. So that's why, at that point of time also, I just state to you, that's why it's very important for us in the code also to see that at the time when the data is too huge, or at the worst case scenario, how it is behaving. So that will be done with the help of a big O, right? So this is something which is very, very important in out of these three. By saying that, because we are a beginner, we don't know anything, so we will try to understand the fundamentals of every particular notation that we have, whether it be big O, whether it be omega, whether it be theta, right? So we will start with the big O first, and then we will talk about the omega and theta. You will understand the significance of all these three once you will be able to get an idea that what basically they're indicating. Okay, so let's get started with a big O notation first. So when we talk about big O notation, it says that any function f of n is big O of g of n. Only when if the value of f of n is less than or equal to c times g of n. For all n where the value of n is greater than equals to n node. Here the value of c is constant, which is greater than 0, and the value of n naught is greater than equals to 1. What is this meaning? Here we are saying, so let me just try to insert one image also. See this image. So try to understand now very much clearly. What we are saying here is that, or what this particular thing is saying, that this f of n is equals to big O of g of n. At what point of time? When your value of f of n is lesser than, if you will see after this point, I hope everyone is able to see my marker, or maybe what I can do using red. After this point, the value of f of n is somehow lesser than the value of c times g of n. What is the meaning of that? Let me give you one example with the help of which everything will be clear to you. For example, suppose the value of f of n, function of n, is equals to 5n. So this is example number 1. And the value of g of n is equals to n. Now, if someone is saying to you that can I write the value of f of n as big O of g of n? What do you say? That internal meaning of this is that the value of f of n should be less than or equal to c times g of n. Means after some point of time where the value of n, here if you will see after this point, the value of n is greater than the value of n naught. So after some point of time, this particular relationship should hold in order to say that the value belongs to big O. That is the intuition. So what you can do is that write the value of f of n, which is 5n, less than equals to c times, what is the value of g of n? N. Now try to understand. Can you write any constant c here? Can you write any constant c here whose value will be greater than 0 and which is a constant to make this condition as true? Yes. If I will write the value of c as equals to 5, or maybe any value which is greater than equals to 5, at that point of time, can I say that this particular relationship will hold true? Can I say? Right? So, because I can say that at this point, and these points are nothing but the constant points, so I can say that this relationship will hold true. Again, I am repeating, please listen again. The meaning of big O notation we are studying here. Big O notation says that any function f of n you can write in terms of big O of g of n if and only if this condition will be satisfied. What is this condition saying? This condition is saying that after some value, which you can see in the graph as well, after some value, which is n naught is some random value. For example, here the value is 2. After 2, all the values of this particular value c times g of n is greater than the f of n. Or in other words, the value of f of n is less than the value of c times g of n. This is the intuition. So whenever you are seeing this term, for example, you are saying the value of f of n is 5n and the value of g of n is n. Can I write the value of f of n is big O of g of n? So what you need to see is that you need to see that this is the mathematical intuition behind big O. Now, can I write this term? Can I write this term as, and this equation can hold be true? Can I write some value of c for which this equation will be true? So you will put the value f of n is 5n, g of n is c, g of n is n. Now, can I write some value of c here, which is a constant, and for which this equation will become true? Answer came yes, you can write. If I can write, then I can say that I can write this equation, this value f of n and g of n in terms of big O. That is the simple meaning. Please ask if you have the doubt. G of n and f of n are the functions, two different functions. F of n and g of n is two different functions. So whenever you are saying that, for example, I gave you one, I talked about this relationship, right? This n factorial and n to the power n are the two functions. So I can write this n factorial as big O of n to the power n. Why? Because if this is f of n, it should be less than or equal to the value of c times g of n, where g of n is other function called n to the power n. Similarly, here also if you will see, f of n is one function, g of n is another function. You can write, for example, f of n is log of n and g of n is n. I am saying that you can write log of n also as big O of n. Why? Because log of n value is less than or equal to the value of n. So here if you will see, what I am writing, the value of f of n is 5n, the value of g of n is n. So can I write this value of f of n as big O of n? I can write only when this equation is true. This equation says that the value of f of n should be less than equal to c times g of n. So what I did is that I just placed the value of f of n as 5n. I just place the value of g of n as n. And then I look forward to calculate what should be the value of c I can write here. C is any constant. Can I write any constant here for which this equation will be satisfying? So answer came, yes, you can write. If you will write the value of c as 5, which is a constant, at that point of time, this equation will become true. If this equation will become true, you can write like this. Okay, let's talk about some another example, maybe with the help of which it would be having a better clarity. Let's talk about example number 2 here. Let me reverse the function now. Suppose you are having f of n as n, you are having g of n as 5n. Can you write the value of f of n as big O of g of n? Yes, I think maximum students now got the point. Why yes? Because when I'm writing f of n as big O of g of n, I can write f of n as less than equals to c times g of n. So I can write the value of n is less than equals to c times 5n. Can I write any constant c here for which this particular condition will be true. Yes, if I will write the value of C as 1 by 5 here, at that point of time, what will happen? The value of n will become equals to the value of n. This equation will become true. If this equation will become true, this will also become true. Right? And we will be able to get the result. So here, this particular thing, if you will try to understand, this thing will hold true at that point of time. Fine, everyone? Yes, we will move towards the false condition now. Let's talk about example number 3. Example number 3. Here, if you will see, suppose the value of f of n is equals to n square. And the value of g of n is equals to n. Now, can you write the value of f of n as big O of g of n? What does this meaning? Simple meaning is that f of n should be less than equals to c times g of n. So here f of n is something which is equals to n square, which is less than equals to c times n. What should be the value of c? Now, many people are saying c is equals to n. But if I will write the value of c as n, it is fine. You will be able to get the value of n square as equals to n square. But is this c a constant? No, right? It is not constant. Whereas here the value of c is directly proportional to the value of n. So at this point of time, you can say that this particular equation will not hold true. So you can't write that value of f of n is big O of g of n. Getting my point, everyone? So mainly, simple thing that you need to understand here is that whenever someone is saying that my answer is, suppose you will be having two values. One is log of n, one is n. Can I write log of n as big O of n? Can I write log of n as big O of n? Anyone? Why? If yes, why? Consider that this is f of n and this is g of n. So here if you will see this condition where log of n is less than or equal to c times n is holding true. Even when the value of c is equals to 1, which is a constant, this condition will be holding true. So sometimes what will happen is that you are solving one question, okay? In that question, you are getting the time complexity as log of n. But in an MCQ, they are not giving the time complexity as log of n, but they have given the value as n. So you can also select that n value if log of n is not given. Because we can write log of n also in terms of big O of n. So whenever the right side is higher than the left side, you can write in terms of a big O. Because log of n is having smaller value as comparable to n. We just now studied, right? We just now studied that n is having a higher complexity as comparable to log of n. That's why it is true. Making sense to everyone? Okay, fine. If it is making sense to everyone, now let me give you maybe few questions so that you will be able to get a much better idea of what I am explaining here. Let me look for some question. Okay. In one side, suppose you will be having this. So problem number 1. Now this is for you all. I will not solve this problem. So according to the understanding that you developed so far, let's see who will tell me this answer. Suppose I am having 1000 n log n. Can I write this is equals to big O of n log n divided by 1000? Is this equation is true or false? According to your interpretation of big O. Many people are saying true. Why? So now what you need to understand is that consider that this is a f of n, and I am saying that this is equals to big O of g of n. This is g of n. Now this will be true only when we know the internal meaning is f of n should be less than equals to c times g of n. Correct, everyone? So I can put the value of f of n as 1000 n log n, which is less than or equal to c times n log of n divided by 1000. Now, what should be the value of c I will put here so that this equation will be true? If I will be able to get any value c, which is a constant, I will be good. If I'm not able to get, then that is an issue. But here, if you will see, if I will write the value of c as 6 times 0, I will be able to get the value. Am I saying it correctly? Right? Why? Because at that point of time, this 1000 will cancel out with each other and I will be able to get the value as 1000 times n log n, which is exactly equal to the LHS. So yes, this is true. Correct, everyone? Value of c is any value, but the value should be constant. That you need to take a important note. Okay. Let's talk about problem number 2. Let's see now who will give me the correct answer. For example, here I am having 2 to the power n plus 5. Can I say that it will be equals to big O of 2 to the power n? So many people are saying yes, but few of them are saying no. Okay, let's see. Again, this is f of n. This is g of n. So can I write like this? F of n, by saying the statement, can I write it will be less than equals to c times g of n? Can I say, everyone? So value of 2 to the power n plus 5 should be less than equals to c times 2 to the power n. Can I say? Okay. Now can I write like this? 2 to the power n into 2 to the power 5 less than equals to c times 2 to the power n. So if I will write the constant value as 2 to the power 5, which is equals to 32, can I say that at that point of time, this condition will be satisfied? And if this condition will be satisfied, at that point of time, we can say that it should return as true. Same thing I am explaining in each and every problem. Problems are different, but the approach I am using is exactly the same. Okay, false example you want. Let's talk about problem number 3 then. So some people are saying repetition. So please see, in this question, if you will see, the question says that 2 to the power n plus 5, can we write it as a big O of 2 to the power n? So this is f of n, this is g of n. So I can, what is the intuition behind that? In terms of big O, it will be f of n less than equals to c times g of n, right? Now, can you think of some value c, which is a constant, and for that particular value, this condition will be true? Yes, we can think. What we can do is that we can just say 2 to the power n plus 5 can be written as this particular thing. And here, if you will see, it's just a multiple of 32. So if I will take the constant as 32, we will be able to get an idea. Less than equal to is the meaning of big O. This is the interpretation of big O, which is given by the developers and the researchers when they develop this notation. Omega is completely reverse of this big O. Omega says, when we will talk about omega, it's very simple. If you know big O, omega is very simple. Omega says a completely different thing. Omega says that at that point of time, f of n should be greater than equal to c times g of n. This is the interpretation of a big O. Big O means we are talking about worst case scenario. Means if you are dealing with, if you will be able to deal with a number 10, then you are already dealing with number 1000. Right? So that's the greater case which is taking into account. That's why it's less than equals to. Omega says greater than equal to, big O says less than equals to. That is the only difference between omega and the big O. Theta says I will take both of the condition. I will work for less than equal to as well as greater than equal to. That's the only thing. And that's the only difference between these three. Okay, let's talk about problem number 3, where I will show you the failure of the same. Okay, so can I write 1 by n, which is equals to big O of n? Why? Why false? Here, if you will see, 1 by n should be less than equals to c times n. Can we write any number here for which this condition will be true? Yes, what should be the value of c we can write here? For which this condition should be true. Before coming to this question, I think this is fine actually. This is fine actually. When you will try to take the value of c as 1, then also 1 by n is less than equals to n. This is true actually. Let me talk about another problem because I want to show you the false case. Problem number 4. Let's work for this. 2 to the power 2n, which is equals to big O of 2 to the power n. Think over this. Can we write like this? Is this true or false? Don't say false because I am looking for those problems which will be false. I am also currently only I am making the problems like that. So it might be the case that it will not come like that. Think over it. See whether you are getting a constant or it is somewhere dependent on the value of n. So here if you will see 2 to the power 2n is less than equals to c times 2 to the power n. Can I say? So now what should be the value of c I should put here so that this condition will be satisfied? Can I write this term as 2 to the power n into 2 to the power n? Can I write like this? So now it is easy to understand. If you will take the value of c as 2 to the power n, at that point of time, you can say that this value is valid, this equation is valid. But now here, if you will see, when you take the value of c as 2 to the power n, it is depending upon the variable called n. If n is high, the value of c will be high. If n is low, value of c will be low. That's why this equation is giving us the false result. Means we can't write this in terms of big O. Because here, if you will see, this c is not constant, but it is depending upon the value of n. That's why. Simple. Now I think we have covered up so many examples, right? C is not upon this n, 2 to the power n, right? Okay. Now we have talked about big O notation. Let's talk about now. If you know big O, everything after that is very simple. That's why I took so much of time in big O. Now, as I told you, when we talk about omega, so let me talk it separately. Omega and theta are very simple now because you already have worked hard for big O understanding. In real algorithms, we will talk about the applications for the same once we will start our actual data structure algorithm. Until now, we didn't started that. So how will I talk about the applications? There are applications in searching, in sorting, in networking of people using graphs. At that point of time, I will talk about this time complexity portion again, so that you will be able to understand the applications for the same. As of now, you don't know those things. So I can't specifically talk about the applications of any of the things, right? Here, just you need to understand that given a set of a code, how I will be able to differentiate between the two codes. For example, the example that we picked up, right? Calculating the sum of a natural numbers. Now you can easily picked up. Why? Because you know that how you can compute the time complexity. So until that understanding, you need to take care of as of now, that if given a code, how will be able to calculate the time complexity, so that you will be able to differentiate between the multiple solutions, right? Okay. Now let's talk about the omega notation. So as I told you that this omega notation is completely different, or I would say the reverse of the notation that we have studied here called big O, because it is talking about the best case scenario. So here it says, omega notation says that f of n is equals to omega times g of n, only when the value of f of n is greater than equals to the value of c times g of n. What is the equation in big O? If you remember, instead of greater than equal to, we were writing less than equal to. So that's the only difference that you need to understand here. That's the reverse. Yes. So here, if you will see, for all n, where the value of n is greater than equals to n naught, such that again, here the value of c will be constant, which is greater than 0, and the value of n naught is greater than equals to 1. If I will try to show you the image also for omega, this is the image that we have. So here, if you will see, after some point of time, which is this value, the value of f of n is somehow greater than the value of c times g of n. That is the thing which is given by the omega notation. Again, what's the significance or what's the inference for the same? Suppose again, I am taking the same example, example number 1, where suppose I am saying that the value of function of f of n is equals to n, and the value of g of n is equals to 5n. Can I say that f of n is equals to omega of g of n? So what you will do is that you will say, what is the meaning of omega? I know what's the meaning of omega. It is nothing but f of n, which is greater than equals to c times g of n. So I will write n greater than equals to c times 5n. So what should be the value of c I will pick here so that this condition will be satisfied? Anyone? 1 by 5. Yes, we can write 1 by 5 here, for which this is a constant. This condition will be satisfied. And if this condition is satisfied, then at that point of time, we can say that, yes, we can write in terms of omega. This is true. Getting my point? Now, for those who clearly able to understand the bigger notation pretty well, they will be easily able to see this particular thing as very easy, right? Once we have spent so much of time in big O, omega is very, very easy for us. Let's talk about example number 2. In example number 2, again, if I will take the vice versa case, where I am saying that the value of f of n is equals to 5n and the value of g of n is equals to n, can you tell me that whether I can write the value of f of n as big O of g of n? Can I write? Who will tell me? Sorry, not big O, omega. Again, the interpretation is same. What is the interpretation? F of n should be greater than equals to the value of c times g of n. So here we will be having 5n, which is greater than equals to c times n. So now what should be the value of c I will put here so that this particular equation will be valid for me. So I can put the value of c as 5, which is a constant. This condition will become true. If this condition will become true, this is correct. This is true. Making sense, everyone? Right? Okay, let's talk about one last example. Example number 3. Suppose f of n is equals to n and g of n is equals to n square. Can I write f of n as omega of g of n? Now people, I think, are making sense of what I want to convey in the session. So here, everyone's answer, as far as I can see, is correct. So here, if you will see, we can write this as f of n, which is greater than equals to c times g of n. So n is greater than equals to c times n square. What should be the value of c we can write here? Yes, we can write 1 by n here, correct? But, okay, with the help of writing this, we will be able to make this equation valid. But what's the issue here? C is not again constant. By writing this, we are indirectly saying that C is not constant. And if C is not constant, if C is indirectly proportional to the value of n, at that point of time, this equation will automatically become false. Any doubt, anyone? Yes, Shanmugam, if I'm spelling it correctly.
Yeah, correct. Yes, Priya. Priya, I am having one doubt here. So the function equal to omega, I mean home of g of n function, right? How we can relate with that complexity? Can you get me what I'm asking? So how can we relate this with the normal execution, code execution complexity?
So in the code execution complexity also, I have talked about the example, no? For example, this is the case. This is the case where people are giving you a time complexity of log of n as well as n. So here, if you will try to understand this part here, that many people, so suppose I am taking one interview,
I mean,
and in an interview, I am talking about you are giving me a solution of log of n. Okay. And I am saying that this solution, can I write it in terms of big O of n? What will be your answer?
log of n is our, I
So
mean,
my question is that you solve your question in terms of log of n.
okay.
Now I am saying that, can I write that log of n term as a big O of n? What will you answer?
Okay. Uh, uh, I mean, the best solution you are asking or the worst solution?
I'm not asking worst or best. I am saying, so let me go below.
Okay.
I am saying that you solved one code and your code is giving the time complexity as log of n, right? I'm saying
Correct.
that, can I write this log of n term in terms of big O of n? Same thing, can I write like this? Is this equation
Okay,
is
got it. Yeah, valid. Yeah, got it.
Can I write this log of n as omega of n? Is this equation is valid?
I think no,
Why? Why no?
because n is, I mean, greater than or equal to, if we give greater than or equal to the constant, so it will not go. It will not. It goes to the false. Why
Bilkul,
means,
yes, it's very much correct. How will
yeah.
you get this understanding of greater than equal to and less than equal to?
Uh, I mean,
By today's session, we
correct,
discussed this, right? So
correct.
if someone doesn't know this greater than equal to and less than equal to concept, what I am
Got it.
discussing today, how will he answer this problem?
Correct. So if there is a two solutions are there, so we can
Yes.
confirm this is a omega solution, this is a big O solution.
Yes. And in
Oh, got it.
technical interviews, mainly they will ask you this question. And I'm telling you, this is the basic things. And 99% students don't able to answer this because they don't know these things. You know, because you listen this lecture.
Yeah, got it.
So that's the important thing. That's why I am saying that each and every bit is very important. I can skip this part. Even if I will skip, you will be able to understand the upcoming sessions. But I want to clarify every fundamentals of everyone, those who are beginners or those even advanced pro level people don't know these things.
Yeah, got it.
So
Yeah,
now if you know these things, no, you will never ever be able to be in a state where you don't know what she's talking about.
correct.
Right? Okay.
Yeah. Okay.
A-
So
Any other doubt?
that,
Yeah.
yeah, for that example you have given in the yesterday you have given one example, right, for Darun and Arvind.
Huh.
So for the solution given by Darun is like worst case solution, and then Arvind is like omega solution. So correct.
So when we
Is my
talk
answer
about the two solutions, so see, any solution you can write in big O also, in omega also, in
omega?
theta also.
Correct.
Three different things are there. Now, when we are talking about Arvind and that other person Dharun, so Dharun says that I will make a for loop. I will use a for loop. In that case, we are saying that it will be big O of n. In Arvind's
Correct.
solution, we are saying that because he is not using any loop, he's directly using the formula to calculate the sum of n natural numbers. It was a constant.
Correct.
Now the same thing. Now, can I write this like this? Omega of n and omega of 1.
Okay.
Can I write?
Yeah, we can write.
We can write. Correct?
Yeah. Okay. Correct.
Even now you will
Got it.
understand theta also. So in
Theta
terms
also.
of theta also you can write.
Correct.
This is a way to write the code. Now, you know, because you understood that what is the meaning of big O here, what is the meaning of omega here, what is the meaning of theta here. But you can write in any of the form.
Okay. Then, wow,
Got it?
Got it. Yeah.
Any other doubt? Okay. I hope that these things clarify others' doubts as well. Yes, Rajshekhar. We will also discuss about theta notation. After that, we will stop the today's session, so that the topic that we are doing here will be completed. And then obviously we will meet after a gap of 5 days. So I don't want to take a pause on any of the topic. Whatsoever I will discuss completely. Yes, Rajshekhar, do you have any doubt? Okay, no doubt. Fine. Now the last thing which we want to discuss in our today's class is the theta notation. Everything is easy so far, right? So if you understand what is big O, what is omega, automatically you're done with theta. Why? Theta notation says theta is the average case scenario, means it says that I will take care of both of the things. If there is some function which will satisfy the big O condition, what was that? F of n should be less than equals to c times g of n, as well as which will satisfy the omega part as well, which says f of n should be greater than equals to c times g of n. If there is function which will satisfy both of these conditions, that will come under the category of a theta notation. Let me import the image of that. See this image now. So there exists some constant. There are two constants here we have, C1 and C2. So from the image, it should be C2, it should be C1. So if you will understand here, if you will see here, there is a point after which, if you will see, this is the point, the value of C2 times G of n is greater than F of n. This, if you will just focus on these two lines, which I am saying, this black one and the above one, this is the condition of big O. And if you will observe this line and the green one, where at this point, if you will observe, at this point, the value of C1 times G of n is lesser than the value of F of n, these 2 points. This is the condition of omega. So if there exists the C1 and the C2, for which the condition will be satisfying both of them, at that point of time, that is something which we called as a theta notation. Let me take one example here so that the understanding will be clear to everyone. Let's talk about example number 1. We'll take the same example. F of n is equals to n and g of n is equals to 5n. Now, can I write this equation as f of n equals to theta of g of n? Think over it and then give me the answer. So what you need to see here is that, first of all, whatever approach we have picked up to understand the big O, take that approach. Means try to see, can I write f of n as less than equals to c1 times g of n? Again, try to understand this c1 and c2 are the constants whose value should be greater than 0, and they should not be dependent on any other value of n. So now they can be different. Obviously, they will be different also. Here also, if you will see, the points are also different with which they are meeting. So they can be different, but the important point that we need to understand is that both of them should be constant. In last problem, if you will see, C is dependent on the value of N. That's why it's not constant. Okay, so here if you will see, if I will talk about this thing, N is less than equals to C1 times 5N. So if I will write the value of C1 as 1 by 5, I can say that this condition is satisfying. True? If it is true, our task is not done yet, because here we are focusing on theta, not big O. So both of the conditions must be true. This and this. It's not an option. You should have that thing that big O and omega both should be satisfying in one go. So now we need to work for, so this is the condition for big O. We worked for that. Now we need to work for omega. So omega says f of n should be greater than equals to C2 times G of n. Now n should be greater than equals to C2 times 5n. What should be the value of C2 I will put here? I think for the same value of C2 it will work. If I will put here also 1 by 5, again this condition will be satisfied. This condition will be satisfied. So here this was the condition of omega. So now in this question, if you will see, big O is there, omega is there. If big O is there, omega is there, you can easily say that this particular condition holds true. Simple thing to understand. Cut the long story short. If any function satisfying the big O as well as omega, you can write it in the form of a theta. So whatsoever questions you have solved so far for the big O and omega is also applicable here. So I don't want to repeat those questions. I hope I am making sense. C1 and C2 are the constants which are not dependent on any kind of function. No. C1 and C2 can be different. But the important thing to understand is that they should be constants. They should not depend on any value of n. For example, if suppose there comes a scenario where big O is satisfying, but omega is not satisfying. At that point of time, simply straightforward, you can say that I can write in the form of a big O, but I can't write in the form of a theta notation. Correct, everyone? So in today's class, what we have discussed mainly, we have started with the discussion of the assignment problem, which I have given to you. After that, we have also discussed about the complexity classes, very, very important. After that, we have also discussed about the asymptotic notations. Now in the next class, what we will discuss? In the next class, I think now we are good to start about there is something called as recurrence relation. Recurrence relation. We will discuss what is that. And in the next class, I will discuss that how we can solve any recurrence relations. There are three methods that we have. One is substitution. One is recursive tree approach. And another one is Master's theorem. And now once these things will be done, then our analysis module will be completed. By next week, analysis module will be completed. Once that will be completed, after that, we will start our actual data structure and algorithm. So far, we have not started. It's just the introductory part which is going on. Once we will start that, after that, those who attended these sessions will not face trouble. That is guaranteed by me. But those who have missed the session, obviously this recording will be gone to everyone. So I request everyone, if you want that in the future classes, you will not face any trouble in terms of calculating what is the time complexity requirement, how basically we can solve any recurrence relation, or basically how given a code we will be able to differentiate between different solutions, then you will face a lot of trouble when we will talk about the data structure and algorithms. That's why it's important. Afterwards, in every session, I will not go in that much depth the way I am going as of now, because I can understand you are beginners. But at that point of time, I can understand you are not beginners, you are expert. By considering that thing in my mind, I will move ahead towards the other sessions where I will directly talk about that, okay, this is the time complexity of this question. You can't ask me that how you are coming up to this time complexity, because I have already taken these sessions in the very initial days, right? Okay. So this is the agenda for the next class. Now, what we can do is that, let me try to give you a few problems before ending this class, and then we will discuss about the doubts that you have. So here, the very first problem which you can solve at your home. So few problems, practice problems. First problem. If suppose the value of f of n is equals to n minus 10 and the value of g of n is equals to n plus 10. The problem is, can I write the value of f of n as theta of g of n? See the term, I am writing as theta here. Next problem, if suppose the value of f of n is equals to n and the value of g of n is also equals to n, can I write the value of f of n as theta of g of n? Next problem. Let me fetch some good problems. Okay. Next problem is, you will be having 64 to the power log of n base 2 multiplied with 32 to the power log of n base 2. Can I write this as big O of n to the power 5? Is this true or false? Another problem is, there is 4 to the power n divided by 2 to the power n. Can I write this as big O of 2 to the power n? I think this much is fine. Last problem I can give to you. There is something which is 128 to the power log of n base 2 multiplied with n square. Can I write like this? Theta of n to the power 9. Now, here if you will see, for every problem, when I am saying, can I write whether this is true or false, you will only able to answer if you know the today's lecture. Otherwise, you can't answer. So if I will give this problem yesterday, I am not expecting many correct results. But today, I am expecting maybe 99% of my class should give me the correct answer, because now you know, when I am saying theta, what is the internal meaning of that? When I am saying big O, what is the internal meaning of that? And when I am saying omega, what is the internal meaning of that? So what I can do is that I will first of all share with you this PDF, and whatever queries you have in this doubt, you can discuss with me in the next Saturday's class, right? We will discuss. So whatever questions I will give, I will discuss for sure, because otherwise it's of no use, because if you have doubts, there should be discussion of that. So this is something today we have discussed about asymptotic notations and complexity classes, live notes. So let me share with you all this so that you will get the access. Anyhow, team will upload the same, but let me also share with you. So this is something which is lecture number 2. DSA live batch, lecture number 2. Perfect. So let me share with you link. You can let me know whether it's accessible or not. Check once. Not accessible. Okay, just wait to everyone. Now check. Yes, got it? Great. Okay. So now those who want to leave the session, they can leave. I already talked about what we will discuss in our next class. And now we are open for the queries. So yes, Siddharth, please ask the doubt.
Hi, ma'am. Am I audible?
Yes, yes.
So my question was like, I understood the entire concept behind the big O notation and omega notation. So my question is like, can we understand this in terms of, so we have f of n and g of n as two different time complexities solving the same problem, right?
Yes.
So when
here we are trying to understand that if we are having two different complexities, can we write it in terms of one another? Can we write it in terms of big O or omega?
When we say big f of n is equal to big O of g of n,
So
no matter whatever we multiply or divide the g of n, that will be the worst case when compared to f of n. Is that true?
Yes. Yes.
That's it, right? Simply
Yeah.
to be very simple. So g of n, when we write big O of g of n, it will be the
Yes.
worst case as compared to f of n.
Exactly.
Right?
Exactly. Correct.
And when we write omega of g of n, that will be the best case as compared to f of n.
Yes. Correct.
Oh, yeah, fine. Thank you, ma'am. That's it.
Okay. Those who ask the doubt, unraise your hand so that I can see and will talk to others as well. Arpit, please ask. Yes, big O is the worst case. So if you will satisfy that, it means other notations automatically get satisfied. It's true. Abhimanyu. Arpit, do you have doubt?
Yeah, hi Priya.
Yep.
I was asking like the way we calculated this big O notation, how do we calculate this theta and omega for that particular, for example, some problem we have?
Which problem? So same approach, the way we calculated for omega also, I showed you the approach, no? Which problem? Tell me, I will solve for you.
You can take any problem. I'm just asking like,
so
while
in
calculating
omega,
big O, we had some rules that we'll remove the least part, we'll only have the bigger part and like that.
yes. So if you will be able to calculate that big O value, so any of the term which you're writing as big O value, if you will be able to solve any question, you're writing as big O of log of n. So at that point of time, this question is already in Abhimanyu is also written. So that is already satisfying that omega and theta thing. Why? Because if you will be able to take a worst case scenario, automatically best case scenario will be covered up. But here, if you will be having two different functions, f of n and g of n, at that point of time, how can you interpret all these three is what we are looking here. Getting my point? For example, let me talk about one example here. For example, you're looking for a element in your array. You are having one data structure where 20, 30, 50, 70, 90, 110, these elements are given to you. This is by default, we will discuss this in our classes. Array index will start from 0. Now your task is to search for any element. For example, you want to search for an element 70. Now, what is the worst case scenario in this case?
Element will appear at last.
What is the best case scenario in this case?
Appear at start.
What is the average case scenario in this case?
Appear in middle.
You only told me the answer. So now if I will talk to you and I will tell you what is the worst case time complexity for this case if I want to search for any element which is present at the very last? So what is the time complexity?
Linear.
Can I say big O of n? Simple linear approach where I will start from 0, I will move on traversing, and at that point of time, I will move here and I will get the linear one. This is the worst case. Suppose I am looking for an element which is 30 or which is 20. Can I say this is at that point of time, this is constant only? I just traverse only single element, big O, omega of 1. Can I say? What is the average one? At average one, I will go until n by 2. So I can write theta of n. So it depends on use case to use case. What is the best? What is the worst? What is the average?
Okay, what I'm asking is like if we have some loop and we calculated the big O notation for that. So if someone asks like what is the best case time complexity for this, then how do we calculate that?
What first thing, whatsoever be the big O you have, you can also write it in terms of omega as well as theta. One thing. Okay. If specifically he is asking to you that what should be the best case scenario here you can expect, just like the way I told you. At that point of time, you can tell to him and you can talk specifically about the best and the average case. Otherwise, you can pre-assume that if you will be able to cover up that worst case scenario complexity, that automatically covered up your theta and omega. So no one will separately will ask from you that what is the omega notation and what is the theta notation for that. Getting my point?
Cool, got it. Thank you.
Okay. Let me unmute other students now.
One more doubt
Yes,
I had
please ask.
was like you said exponential versus quadratic, right? So in exponential, if we like take 2 to the power n, and the other thing we are comparing is n square, that is quadratic. Then it will depend upon the value of n, that which one is bigger, right?
Again, we are talking about big O, so we are considering the bigger values only. Who will take care of 2 or 3 values? If you will tell to me that, ma'am, if you will take 3 square here and 2 to the power 3, somehow it is coming up small and it is coming up larger. But my question is, are we dealing with 3 numbers anyhow in practical real life scenarios?
Yeah, got it. So for bigger values of n.
Always assume bigger values. Always assume worst case scenario. In all the sessions, whenever you are solving any problem, never solve for small problem. We always dealing with a hard problem. Got my point?
Oh, last question.
Yes.
So when we are calculating this theta or omega, when we take g of n, this g of n function will be always same as f of n, right?
Will always same meaning?
Like you are taking...
It can be different. I took f of n as log of n in one of the example and g of n as n, if you remember. This is different, right?
Yes, so f of n is the complex equation that we derive from the time complexity analysis of that particular code. What is g of n?
G of n is some other way to mention that. For example, I showed you one relationship today that n factorial is lesser than n to the power n. Suppose in your question you solve the problem and you got the time complexity as n factorial. So I am saying to you, can I write this n factorial as big O of n to the power n? So this is g of n in my question. G of n is something bigger than f of n. So can I write like this? Yes or no?
Yes.
Yes. So it can be same, it can be different. Anything they can ask from you. But you should be aware about the fact that what is the meaning of big O. Getting my point?
Cool. Thank you so much.
Okay. Meanwhile, Kiran.
Hi there, Priya. My question is, for the theta, can we say when C1 is equal to C2, that's the average case scenario?
C1 and C2 will it's the here in this example we got the same values, right? C1 and
Correct.
C2. But
I understand
it's
C1
not
and
always
C2
the
might not
case.
be equal.
Yeah. Now ask the question.
Okay, that's what my confusion was. Like when C1 is equal to C2, that will be the condition. I mean the true condition for theta.
When C1 and C2 are equal, that can be a
that
theta notation. You are saying it correctly. But what I'm saying is that when C1 and C2 are not equal, but still they are constants. For example, you are getting some value of C1 as 5, you're getting some C2 value as 3. Still also, you can say that they belong to a theta notation.
Okay, got it.
Doesn't matter they are equal or not. Simple fact is they should be constant. That thing you need to keep in your head. Fine?
Got it. Yeah, thanks.
Any other doubt?
No, that's all. Thanks.
Okay. Yes, Dikshant.
Hello.
Yes.
Yeah, ma'am. So individually, the topic is clear. So, but what about we have if we have to we have to this relate to the in terms of code. Suppose I have a while loop, and just like you explained yesterday, while loop and a statement, couple of statements, and now we calculated the big O notation. Suppose it comes to a big of log of n. So if so, this is a worst case scenario. So if you are, if someone asks to in terms of omega or theta, so it is best or theta case value. So we need to calculate that theta and then write a code again in terms of theta notations.
So when you will tell to them the worst case scenario, automatically you covered up the best and the average case. There is no need to specifically mention that. And even when we move towards the coding part, then I will maybe better explain you that part, that how basically you will let them know what is theta and what is omega if they specifically ask from you. Getting my point?
Yes.
So when we just wait for, I think, just after next week class, you guys will be able to get much better understanding of the things which we are covering up today. But that's what I am saying. If you will be able to understand 50% of the session, it's completely fine to reach to a point where I want you guys to reach. Because at that point of time, when I am talking about what is the time complexity, I just want to tell them that, okay, my students should know that how we can basically evaluate that time complexity. At that point of time, I don't want any trouble for me as well, because if you don't know, it's a trouble for me, right? That's why I just covered up a brief about all these things in this particular part only. And when we come towards the coding part, it's not like that I will not discuss the time complexity. You will see it every code. After every code, I will discuss the same thing. So at the very end, you will be pro in this. I will be for sure in that part. So when we will cover up, when I will write the code with you, and then I will show you the complexity, at that point of time, you automatically will be able to get what I'm saying here, and you will not face any trouble. But as of now, just keep this thing in head, that what's the meaning of these things. That's it. Getting my point?
Yeah. Okay, thank you.
Vidut?
Good evening.
Good evening.
Yeah, I have understood whole lecture, ma'am. I have doubts in that assignment problems.
Yes, please ask.
In that assignment problems, ma'am, I have not understood that logarithmic part, ma'am.
Where is that?
In the second and third problem, ma'am.
Can you solve this equation?
Yeah, no, just the last line, ma'am. How you are calculated that?
Forget about my code, my equations. Can you solve this equation, this mathematical equation? I am asking from you to solve this equation. How will you solve? Can you tell me the steps? Let me remove my steps. So the problem here is coming up because you guys are seeing the approach with the help of which I am solving the maths equation. But you guys are enough capable to solve any mathematical equation. This is what I believe. Tell me, how will you solve this equation to get the value of k?
Yeah, 23k, ma'am. It will come. at the start. So it will be
Okay.
like 23k log n 29
Who
equal
will
to,
tell me how we can solve this equation? By steps, by unmuting themselves. Mohan?
Yeah, am I audible, ma'am?
Yes. How will we solve this equation?
Basically we can multiply with n on both sides.
Multiply with?
N on both sides.
Okay, here it was n, sorry. We can, what is the equation actually?
Yeah,
Equation was this.
Correct on.
So I am having this equation 29 to the power 23 to the power k, which is equals to n. How will I solve this equation?
Yeah, I think he can understand now. He is confusing because there is log n, I guess. Am I right? Whoever is speaking, the other guy.
yeah.
Yeah.
So can you solve that, please? Can you give me how to solve?
Yeah, okay. So we can multiply with log n on both sides.
Okay.
Okay, why we are multiplying with log n?
To make the right side as 1.
Okay. So he's saying multiply with log base n.
Sorry, not log n, log 29. Log 29.
Log 29. 29 is the base, you are saying.
Yeah, I'm sorry. Yeah,
that would be much simpler.
Yes, log 29.
Okay. Okay. Yes, that also we can do. Okay.
Yeah,
Then
left side this log 29, 23 will come before the log, 23 power k.
okay. So Vidut, in whatsoever steps you feel like, just let me know. Okay, he's saying like this, so I did like this. Now this will become 1.
Yes.
Now
23 power k. Yeah.
So here 23 power k will become log of n base 29.
Yes.
Now
And
what should we do?
Log of 29.
I need k.
23.
So can we do log base 23, which is equals to
Yes.
log of 23 log n base 29?
Yeah.
This k again will move up front. So log 23 base 23 will be 1, which is equals to log n base 29.
Yeah.
So this is not data structure algorithm. This is mathematical equation that we need to solve to get the value of k. It's just that you should know the basic properties of logarithmic. If you are not aware about that, let me do one thing. In the next session, I will give you maybe one flow chart, something like that, where I will write some properties. At least those properties you should know. That's it. You don't see my approach of solving any question. See the logic behind that, and after that solve it on your own. Right? Yes. Where is Vidut? Is it clear now?
Yes, ma'am, it's clear. Just, ma'am, that last step, ma'am, k is equal to the log 23. How that comes, ma'am? Last step.
So here, if you will see this equation, this is clear, this equation?
Yes, clear, ma'am.
So here, if you will see this k part, we will move ahead.
Okay.
Log 23 base 23 will be 1. So k into
Okay.
1 is k is equals to log base 23 log n base 29.
Okay.
I think it's not clear. So here,
Yes,
what we are doing is that we are taking, we are taking log base 29 on both sides. So here log base 29, log base 29, second step. Is it clear?
Yes, understood, ma'am.
After that, what we are doing is that this is the power term. It will go ahead. So 23 to the power k log 29, 29, log 29 n.
Yeah,
now
understood,
this
ma'am.
will be 1. Is this clear?
Understood,
so
ma'am.
what we are getting? This.
Yeah.
Now what we are doing is that we need k. Still we'll need k. So 23 is the trouble. So what we can do is that we will take log base 23 on both sides. So log base 23 here, log base 23 here. Fine.
Okay.
Now this k again power is there. We can move ahead. And log 23 base 23 will be 1.
Yes, understood, ma'am. Clearly understood.
Great.
Ma'am, third example also, ma'am.
Third example, now try to solve it on your own. It's again a logarithmic property you need to apply. Even if you not apply, this example is very easy. You just take a very large, just take some number with the help of which you will be able to understand the relationship between them. That's so easy. Try it your
Okay,
home.
ma'am. I will.
And it is having an issue, do mail me or ask me in the next session.
Okay, no problem, ma'am. And ma'am, just please provide ma'am logarithmic properties flowchart and algorithms if possible, ma'am.
In next session, we will discuss. Not an issue.
And ma'am, one more doubt I have in the last problem. I think problem number that that sees that not constant in some problem, ma'am. Why that it's not this dependent on some.
This one.
One problem is. Yeah, ma'am. Yeah, why that C is not constant, ma'am? I have not understood that.
So here on the left side, we are having 2 to the power n into 2 to the power n. On the right side, we are having C times 2 to the power n. So what should be the value of C I will put here so that this equation will be satisfying?
Yeah, 2 raised to n.
So
means if you put 2 raised to n, then 1 2 raised to n and other 2 raised to n will be cancelled.
Okay, cancel. How it will be cancelled? 2 to the power n into 2 to the power n. How it will be cancelled?
No, after putting the value of C.
C value, if I will put 2 to the power n, so this is the equation which I will be able to get.
Yes.
So here, if you will see, this C is dependent on this n. N factor is there, right?
Yes, ma'am.
That's why it's not constant. So if you will put the value of n as high, your value of C will be high. If you will put the value of n as low, the value of C will be low.
Okay, ma'am.
That's why it's not a constant. Constant meaning some number, 2, 3, 7, 30, 40, 1000. It's not a constant value. It is dependent on the value of n. That's why.
Okay, ma'am.
Getting my point?
Yes, ma'am. And one more problem that same C is not constant, ma'am. In that problem also. That also. I think.
Which problem?
I think in omega notation. I think, ma'am. Was that
this one?
Ma'am.
So here also, if you will see, it is dependent on n. Is this some number? 1, 2, 3? No, it's not a number. Here it is saying that C is indirectly proportional to n. If I will increase the value of n, C will decrease. If I will decrease the value of n, C will increase. So that's why it's not a constant. Constant meaning any number. If it is not a number, it is dependent on the value of n at that point of time. It should not be omega or big O notation or theta.
If it is directly proportional, then ma'am, it's problem.
Anything directly, indirectly, there should not be any dependency on n. As simple as that.
Okay, ma'am, understood.
Okay.
Yeah.
Okay.
Thank you so much, ma'am.
No problem. Yeah, Siddharth.
Ma'am, so you told me like we can write the same thing in terms of big O notation, omega notation, and theta notation as well, right? So can you take a very simple example and write in terms of all three notations? No?
One example I just gave you, right? Where suppose there is some problem solved by Dhruv and some other person.
Yeah, whatever. Basically, finding the sum of
n natural numbers. So here we are getting in one of the code big O of 1, in one of the code big O of n. So this can also be written as theta of n, theta of 1.
Yeah, so this is what I didn't understand, ma'am. So can you just stress on this a little bit more, like how are we writing this? So when you write big O of n, that will be the worst case. So no matter whatever f of n would be, like there is no other case better than, I mean, worse than that. That's what it means, right?
Yes. So
and then how are you able to big O of 1 for that, the upper one? That That would be
When
so. That would be
could you
the
repeat
best case right now.
what
So
you are
not
saying?
big O of 1 would be big O of 1 would mean that there is no worst case apart from that would be the worst case as compared to any other functions, right? Big O of 1. That is what it means, no, ma'am.
Big O of 1 means that in this code you are having constant time complexity. For that code, you will be having a constant time complexity. Means there is no loop which is working on in your code.
So it doesn't mean okay. So big O of 1 doesn't mean that. Hello, ma'am.
That
Yes,
yes, please say.
Yeah. So big O of 1, it doesn't mean that that is the worst case. So constant time complexity is not the worst case for that particular problem. Is that what it means?
See, you are confusing between the problem and the solution.
Yeah,
Here,
exactly.
what is happening is that what I am saying is that for a problem, you will be having maybe 5 solutions.
Yeah, we
or
don't know
4
the number of
solutions.
solutions. But
Okay.
but
For
you
every
but earlier you
solution.
considered yeah.
For
So but
every.
earlier you can
Huh? Please say.
yeah, ma'am. So we don't know how many solutions are there for a particular problem. And while writing these notations as big O of n and omega n, but you are considering 2 solutions, right, ma'am? So
for those 2 solutions, we will be having a different big O value. In one, we are having big O of 1. In another, we are having big O of n. Can I say?
No, ma'am. So when you are considering any notation, you are considering 2 particular solutions and comparing only those 2 solutions, is it?
Yes. Yes.
Okay, but how can you write big O of 1, ma'am? Because that would mean that will be the worst case for that thing as compared to what?
Big O of 1 meaning that in this solution S1, you are not using any loop. There is no loop.
Then why big O of, ma'am? It can be omega of 1, right?
No. For every solution, you have big O, omega, and theta.
Okay, so what is omega for S1 then?
Same. So if you will be cover up this big O part, omega and theta is also same. It's also constant. For this code S1, for this
Then
code
why do you
S1,
write omega? Then why do you write big O of 1, ma'am? We can directly write omega of 1, right?
we always used to write big O. Because if
That's
we will
the
be able to
convention.
cover up worst case scenario, automatically best case and average case no one will ask you. It's like the same situation in the practical real life scenario, the example which I have given you. If suppose
that thing
someone
I
is there
understood,
in
ma'am.
that
I'm just
worst case,
confused with these.
best case
All
automatically
that I
covered up.
understood, ma'am.
So
Yeah,
that's why here
I
no one
understood.
will ask you the theta and omega. You will always represent it in terms of big O. So in this code solution S1, when you are using the simple direct formula of n into n plus 1 by 2, you are not using any loops, and that's why it is big O of 1. Getting my point?
Okay. So when you say for solution S2 big O of n,
yes. So in this also,
depends on n. It is a function of n.
Exactly.
And any other functions, I mean, there is no other solution worse than this.
Yes.
Okay.
There is no any solution in S2.
There
might be the case in S3, you will be getting the same code
There is
order
no
of
other
n square.
worst time complexity in this solution.
In this solution, I'm not comparing with others. For that, I am saying, for that code, I am referring.
Okay, so for this solution, there is no other worst time complexity. This can be the worst time complexity part.
Yes. Fine.
Yeah, cool, ma'am. Thank you.
Okay.
Good evening, ma'am.
Yes, good evening.
In complexity example, big O, where we just C equal to 1, we just see over there. Right here. Little down, I think. It's example number 3.
C
Not
is equals to n.
C is equal, no, C is equal to 1.
Where is that? Okay, this one.
Yeah. So this one is true or false?
What do you think?
I think it's actually need to false, because over here satisfy only less than, but not the equal. So if I need to satisfy on the equal, so we need to put the value C is 1 by n.
No, anything. So less than or equal to. It's not like that equal to also should be satisfying.
Okay. So less than or equal to, yeah, is less than and equal to.
There is a concept of there is a concept in this big O which I haven't covered up, and I will not go in that much depth also, because that's not that much required. There is something called as, but as you asked the question, there is something called as tight upper bound or tight big O.
Okay.
And then there is something called as loose upper bound, which is called as loose big O. When we say tight, that says that both of them will be satisfying. When we say loose, any one of them will work. Usually in industry, whenever you're going for any interview or anything, and even in our course also, we will talk about loose big O, where we are saying that anything among them will be satisfying, we will go with that. We will denote it as a true thing.
Okay. That's why in the theta we actually take the greater than and equal to, right?
Yes.
Okay. That's
Fine.
why I confused. Okay, thank you.
So specifically, I don't think people are very much into tight big O notation. If they are, then you should know the meaning of that I told about.
Okay, ma'am. Thank you, ma'am.
Okay.
Hello, am I audible? Am I audible?
Yes.
So while taking the values of f of n and g of n, you said that the g of n should be greater than f of n. So the values of both can be anything.
Can be
Like
anything, meaning?
You said na कि g of n should be greater than f of n. So how we take the both values? The values of g of n.
You don't need to take that. Whenever you will write any code, you will be able to calculate the time complexity just like the way we calculated. Now, if suppose you want to compare between the two functions, for example, one is log of n, you will be having. So can you write this log of n as big O of n? So automatically you know that this is f of n, this is g of n. So can I write like this or not? If there is some confusion here that what is f of n and what is g of n, please wait for few more sessions. After that, I will talk about the proper algorithms and the data structure. In that, you will get a better understanding. Again, I will repeat these things again, that here this is f of n and this is g of n. So we are not manually calculating anything. Automatically, when you write the code, you will be able to understand that what is this f of n and what is this g of n.
Yeah. I understood. I was just confused about how to take that values.
Don't worry. You will see when we do the implementation.
Yeah. Clear.
Okay.
Yeah. Thank you.
Okay, then I believe I have covered the doubts of maximum students. Yes.
Hello, ma'am.
Yes, please ask.
Hi, ma'am. I had a question about the function itself. Basically, it's a. I just wanted to confirm. So basically, fn and gn both are the result of the function, right?
Yes.
If I am checking this.
Yes.
So I just wanted to know that the const what it is representing, because we are taking this in a priori analysis, right? So what is the C? Basically, that's what I was thinking.
C is any constant. It simply indicates that that suppose you will be having some function, by adding some any constant, can you make it big or theta or omega? C is some constant. By adding that particular constant, can you make that function as a big O, theta or omega? C is nothing but it's a constant.
Okay, so basically it is a condition we are using to manipulate which standpoint it is getting
Exactly.
into, right?
Exactly.
Okay, okay. Thank you. That's all.
Right?
Hi, Priya.
Yes.
Hello.
Can you please
Hello?
show an theta example as false where big O is true and omega is false?
When you do these problems which I have given you, you will find out the example where it is false. So try to do it at your home, then we will discuss the problem. Here in that, there is a few examples in which it is false.
Okay. Okay.
Actually, ma'am, I have my doubt in that area, wherein actually we have seen one of the examples that we have taken the f of n as log n and g of n as n. So it was actually satisfying big O notation, but not satisfying
omega.
Omega. Okay. But again, I don't know whether I have grasped the contents correctly or not. We have said that if a function is satisfying big O, then it will satisfy all other notations, right?
Now there is, so you are interpreting it wrong. At that point of time, for that particular scenario, when we are talking, when I am making that statement, when you will do the implementation, at that point of time, you will get a sense of that statement. So don't go with that statement because until now, we didn't did any implementation.
Okay.
As of now, see over here, you have f of n and g of n, which is given to you. How it is coming up, I will show you when we do the implementation. Then you will get a sense that whether it is big O, omega or theta. That statement is valid when you don't have as such. So at that statement is valid when you are covering up any worst case scenario where the value of n is very large. So at that point of time, the interpretation is that if you will be able to cover up for that statement where the value of n is large, automatically the best part or the average part will be able to cover up when the value of n is very small or it is in between.
Okay.
But these two lines are different. Today, what we are understanding is something different. Tomorrow, when we understand that part, you guys will be able to get the clarity of that point as well.
Okay. Okay. Good. Thank you. Thank you. Thank you.
Hello, Priya.
Yes, Vidut.
In some f of n in big O and also omega and also that other part also theta also big O is equal to, f of n is equal to the big O of g of n, that greater than and less than condition is predefined on that condition, or it is already set that conditions like that for big O is like for less than and for omega is like greater than, like that.
This is already predefined.
Okay, yeah.
So when this concept came into picture, at that point of time itself, this is the intuition which is defined by the term called big O notation, omega notation, and the average theta notation.
Yeah. Thank you so much. Okay. Yeah. Your teaching is really good. Yeah. Thank you.
Yeah. Thank you so much. Shubham.
Hi, Priya. In both these cases, like in omega and big O, the condition is quite same, right? It is less than or equal to, or greater than or equal to. So the equal to thing is same in both these conditions, right?
Yes. That is the point where theta is coming into picture. So wherever both of them are equal, theta will be the place to write on.
Okay, so I thought the constant could be same in both these.
No. Constant can be different. As I already talked about this thing, that when the constant is same, definitely theta is the case. So thinking is correct, whatever you are saying. But don't say that only when the constants are equal, then only you will get the theta notation. No. When the constants are unequal also, but they're not dependent on the value of n, then also you will get a point of theta notation. Okay? Okay, then guys, I think if you still have any sort of doubt, I have taken a lot of questions and lot of queries about these 2 sessions. Then also, if you will have doubt, you all have my email ID, priyabhartia@ineuron.ai. Do mail me. I will respond you back for sure. And those queries which are still not clear, you can ask me in the next session. Try to be 5 minutes before, so that 5-10 minutes we will take the queries, and after that we can start the session. Content wise, everything I have shared. So I think we can now stop the session, because very soon there is another meeting in this particular platform. So I think we can end this session. But I hope all in all, whatsoever we have covered up is clear to everyone. Am I saying it correctly?
Yes,
right?
Priya.
Okay.
Yeah.
Thank you so much. Bye-bye, everyone. Revise all those things whatsoever we have covered up in this week class. And next week, we will continue our sessions. Bye-bye.